So today we start discussing sheet 7, the one on trigonometry. So the first question. Question 1, part A. Want to express sine of negative 194 as a trigonometric function of an acute angle. So the other techniques that we can use, which include looking at the angle being negative, implying the clockwise direction. That is, if we've got the Cartesian plane like this, it means we're starting from here. We are going this direction like this. Okay, those just joining, can mute yourselves. Okay, so like we've got the Cartesian plane and then we're starting, we are rotating in that direction. So when the angle is negative, it means we are rotating in a clockwise manner. So this technique can also be used. But then I would love us to use the fact that the sine function, can you mute yourself? Immediately join and mute yourself. So we love to use the fact that the sine function is an odd function. So if we're to use this fact, it means this can be written as negative sine 194 degrees. So 194 degrees, this is an angle in the third quadrant. It's an angle in the third quadrant. So you have like this, and now you're rotating in this direction. Okay, that's your terminal point. So you're rotating in this direction, like this. And then, so this is your terminal point. So this angle is 194. This angle is 194. We are no longer going the clockwise direction because we have used the fact that sine is an odd function, and so that negative which was attached to the angle is been put out according to this concept which we are using here. Oh, Eunice, you can't hear, you can't hear me?
Sorry, Daddy.
Okay, if you fail to mute yourself, I'll remove you and make progress. Okay, so this is the angle that we have. Yes, Felistas, remember.
What are we?
Pardon? We're discussing sheet 7 on trigonometry. Okay, so we can proceed. So you observe that this angle is 194 degrees. That's the angle that we want. And so we've got our triangle in the third quadrant. We've got our triangle in the third quadrant, and then we've got an acute angle here. This is our acute angle alpha. Okay, so you know that when obtaining an angle in the third quadrant, you add some acute angle on 180, isn't it? So this gives you some theta in the third quadrant, isn't it? Okay, so now our area of interest is to express this angle in terms of the acute angle here, this one, which is our reference angle. So how do we find this angle? Since our theta is 194, so we can put 194 here, and so for alpha. So we have 194 degrees equals 180 degrees plus alpha. So which gives us alpha is equal to 14 degrees. So the corresponding angle will be negative sine of 14 degrees, I mean. So we would have expressed this angle in terms of the acute angle. Okay, we proceed. We move on to the next part.
Don't you have?
Okay. Then the second part, we'll have to express the cos of 481 degrees as an acute angle. Okay, we can do this in the next page, the next screen. Cos 481 degrees. Okay, so 481 is an angle. If we begin our rotation from this point, we are going in a clockwise manner. When we reach here, we have rotated already 360. So we continue, when we reach here, that is 360 plus 90. Plus 90, which gives us 450 degrees. Then there's some angle. So our terminal point will be in the second quadrant. That's where our terminal point will be. Okay, so we have this as our acute angle. This is as our acute angle. And then since we had rotated up to this point, and it was 451, and then the angle given is 481. So it means we need, when we rotate up to a measurement of 450 degrees, we need some 31 degrees. So this angle here will be 31. This angle here will be 31 degrees. Wonderful. So now, we observe that cosine in the second quadrant is negative, right? Cosine is negative. And then what can be this reference angle, the acute angle here? That's the angle between the horizontal axis and the terminal point. What will be its value? If from here,
59.
pardon?
59.
To be
59.
59 degrees, eh? Okay, so this angle is 59 degrees. And now because cosine in the second quadrant is negative, so this will be equivalent to, negative cos 59 degrees. Okay, so this is the required. Be sure that you mute yourself when you just join. Okay, we can go to question 2. We can practice the other two on question 1. Question 2. Write down the values of the following, leaving your answer in terms of sides where possible. Okay, so the first one, question 2, is the cos of 7 pi over 6. So 7 pi over 6 can be simplified. We can write this as the cos of 6 pi plus pi over 6. Okay. Now, this is just a common denominator. This is a common denominator. It means you can still split the two fractions and write cos of 6 pi over 6 plus pi over 6. Okay, which gives us cos of pi plus pi over 6. So we have cos of 6 pi over 6 plus pi over 6, which simplifies into pi, cos of pi plus pi over 6. Now we are adding the angles here. So we're going to use the double angle property for cosine. The double angle property for cosine, in case you have forgotten, cos of angle A plus angle B is cos of A, cos of B minus sine of A, sine of B. So when you're adding the angles here, when you're adding the two angles, note that in between here, you're going to subtract time. So this is the double angle identity for cosine. Okay, so we're going to use this identity. So expressing this in that form, we have cos of pi, then cos of pi over 6 minus sine of pi, then sine of pi over 6. And we know that pi over 6. Now we have pi 180 degrees divided by 6. This gives us 30 degrees, isn't it? Which is a special angle. So in case you've forgotten, the cosine and the sine of 30, you can derive using those triangles which you did in class, where you had an equilateral triangle. In that manner, these sides are all equal. Then we divided this triangle into two, like this. So if the triangle is equilateral, clearly the angles are equal, isn't it? So this angle is 60 degrees. This angle is also 60 degrees. And the other angle is also 60 degrees. Now, when you divide, we cut this halfway. When we cut this halfway, it means this will be 30 and 30 in the other half. So equally this distance here, when we cut half of this distance, which is of length A. I don't want to use A1, others might have questions, why is it A1? Okay, so this length of this A length will be divided into two, so that we have a triangle in this manner. This remains 60. So this is 30, and this is 90. This is A, so this remains half A. And now using Pythagoras Theorem, you can find the length here. That is A squared minus half A squared, isn't it? Minus half A squared. So you can get the length here. So you have A squared minus half A squared gives us this. And so we have 4 over 3 A squared. This gives the size of one adjacent, the square of the side, the square of one adjacent, of which introducing square root here implies one adjacent is root 3 over 2 over 2A. So that becomes, can you mute yourself? Root 3 over 2A. So that becomes the length of that side. So now, if you want cos of 30, it is just opposite. The opposite, which is half A divided by the hypotenuse. Implying that cos, kindly mute yourself. If you fail to mute yourself, I'll remove you. Okay, meaning that cos of 30 degrees will be equal to, you know that cosine is adjacent, isn't it? The adjacent is this part of hypotenuse. So we can get the adjacent is root 3 over 2a divided the hypotenuse divided by a, isn't it? And so
Sir, why can't you use just 1 instead of a? Because it seems to complicate.
oh, someone also might ask a question. Why are you using 1? Where is the 1 coming from?
So like we're just familiar with 1. Let's just use 1.
Oh, okay, I see. I get you. Okay. So when you divide the 2,
Yes, sir.
you know, it is a simple definition, you know. So you're multiplying by 1 over a. So you observe that these 2 still divides out, and so you remain with root 3 over a. So you are familiar with 1, you can use 1, eh? It is 1 and the same. Eh? So you can also get the sign in there. Okay. So you can also get sine 30 in the same manner. So let's proceed. Cos pi, you know that pi is a common angle. Pi is a common angle, which is 180. So cos of pi is what? -1 by, then cos of 30 is root 3 over 2 minus sine of pi. You know that sine is a common angle. Sine 180 is a common angle. So this gives us a 0. Then sine 30 gives us what? Sine 30 gives us half. Okay. So multiplying by 0 here, it's a 0. So we just remain with negative of that. So we get negative root 3 over 2 as the required angle. We can go to the next one. Unless there are questions on this one.
Don't wrap that, sir.
So I can pause for a short while.
Don't wrap. We're still copying.
Okay.
You can wrap now.
So we go to
You share the working board, though.
Pardon?
So we proceed.
So we can go to the next screen. We're doing question 2, part 2 now. And for the sake of those who just joined late, we're discussing tutorial sheet 7. Okay, on part 2, we've got sine of 9 pi over 4. So this we can write it as sine of 8 pi plus pi over 4, isn't it? Because adding the 2, adding this and this gives us the 9 pi which we have there, isn't it? Okay, wonderful. So these are just fractions. It implies that this 4 was a common denominator. So we can split the fractions and have 8 pi over 4 plus pi over 4. This is where this came from. Since we're experts at simplifying fractions, I believe you understand. Then we can now use we can simplify this. We have sine of 2 pi plus pi over 4. Then using the double angle identity for sine, sine of A plus B is equal to sine A plus B plus cos A sine B. Okay, so we make use of this identity. So we obtain sine of 2 pi cos of pi over 4 plus cos of 2 pi sine of pi over 4. Recall that pi radian is 1/8, isn't it? So meaning that this over 4 will have 180 degrees divided by 4, which gives us what? Which angle in degrees? 45 degrees, isn't it? Gives us 45 degrees. And 45 degrees is a special angle. In case you've forgotten the sine and the cosine of this special angle, you can derive from the isosceles triangle. Where you had this to be of unit length, even this to be of unit length, so that this can be root 2, isn't it? So that can be root 2. So since the triangle is isosceles, it means we have 45 degrees here. And also the other angle is 45 degrees. So when it cuts, we are going to log in again. My Zoom is almost timing out. So we are going to log in again using the same link. Okay. So sine 45 is opposite of hypotenuse, meaning that we have sine 45 degrees, which is pi over 4, is equal to the opposite is 1. The hypotenuse is root 2, which you can write as root 2 over 2. You remember sides, eh? Okay. So equal for cos 45, it will be the same. Let us now simplify this. And then 2 pi is a common angle. 2 pi is a common angle. Sine 360, we know it's 0. You have 0. And then cos 45 degrees, we found root 2 over 2 plus cos 360 is a common angle, it is 1. Then sine 45 degrees, giving us root 2 over 2. Okay, which reduces to just root 2 over 2 as the required value. Can we move to the next one? Okay, we move to the next screen.
No, wait, sir.
Okay.
Sir,
Yes, please.
how can I prove that 1 over root 2 is equal to root 2 over 2?
Okay. So let us do that together. Use a different color here. So we are saying that sine pi over 4 is equal to 1 over root 20. You know that this is equivalent to saying 1 over root 2 multiplied by 1. Does multiplication by 1 change anything? Doesn't change anything, eh? So
Yeah, it doesn't.
wonderful. So multiplying this value by a 1 doesn't change anything. It still remains this one. Now we can write this one in form of root 2. This one here, we can write it in form of root 2. Since we want to rationalize the denominator, so we're going to write the 1 as 1 over root 2 times root 2 over root 2, isn't it? Since we know that
Yes.
root 2 divided by root 2 still gives us this one, right? So meaning at this stage, we have not changed anything. So let us now multiply the numerators. 1 times root 2.
I understand now.
Oh, you get it, eh? Wonderful. So this gives us root 2. And then root 2 times root 2 gives us 2.
Yeah.
Yeah, that's how we got that one.
Thank you, sir.
You're welcome. We'll move on to the next screen.
Yes, please.
Okay. So for the sake of latecomers, okay, we are on question 2, part 3 now. We want to evaluate cos. What's the angle on part 3? So we want to evaluate cos of negative 5 pi over 3. We can write this as cos of pi minus 6 pi over 3. So we clearly see that pi minus 6 pi is the one that gives us negative 5 pi, isn't it? So the expression is equivalent. Okay, so there's this, Eunice says, can't hear me. Are you able to hear my voice?
Yes,
Yes,
I
sir.
am.
Okay, okay. So let us now express this using the double angle identity for cosine. But before that, let us try to split the two. To split the two, since these were different fractions, that were expressed as a single fraction. So we have cosine of pi over 3 minus 6 pi over 3. This reduces to cos of pi over 3 minus 2 pi. Okay. So at this stage, now we can use the double angle identity for cosine. We had written this cos of A by cos of B. Okay. Minus, this gives us sine of A sine of B, which is equivalent to cos of A plus C plus B. So we're going to use this identity to expand what we have. So using that identity, we have cos of pi over 3, then cos over 2 pi minus, now in this case, we're having the two angles subtracting. So we use the other identity here. So the one that you want to will now have a plus. You have cos of A, cos of B, plus sine of A, sine of B, which is equivalent to cos of A minus Bn. So that is the identity we use. So when you're subtracting the angles here, when you're subtracting the angles here, it will be a plus. Take note of the difference between the two properties. Here it is a plus, but on the first one, it is a minus. And we're using this identity, cos of A minus cos of B, because it is a subtraction here of the two angles. We're finding the difference of two angles here. So we use this identity. Okay. So we're going to have plus that's sine pi over 3 sine 2 pi. Also, you have to take note pi over 3, we are going to decrease divided by 3.